Hello. In this video, I'm just going to look over a few examples of some AP statistics questions as per request. But let's just go. I've got a bunch of problems here. I'm just going to go straight down the line. What I put up on the top in the blue are some just simple formulas to deal with uh, probability and statistics. And basically the combination one, remember that's the rule where if we've got a certain number of objects and we have to choose an R number of them and order doesn't matter, then we do this. If order does matter, it's permutation. We use this one. And then I'm going to talk about this one in a minute. We talk about if we're going to try to find the probability of events, sometimes it's helpful to figure out, well, what's the probability of the event actually happening? And if we want to find what's the probability of it not happening, we know it's just going to be 1 minus that. Okay, so just a way you can think about it, because there's different probabilities, it's easier to calculate one of these things versus the other. All right, I'm babbling a little bit, so let me just jump straight into an example problem here. All right. So for the first one, 10 equally likely symbols, 3 wheels, and it says at least 1 bar we automatically lose. We do not get any bars, we win a specified amount. So we have this idea here that if we don't get any bars, we win something, and then the question is, what's the probability of playing twice and winning both times? Well, to answer this question, first off, we just have to figure out what is the probability of winning once, and then if we're going to do it twice, we just multiply those two probabilities together, right? Okay, so let's figure this out. What's the likelihood that you would not get a bar? Well, if we've got 3 slots, 1, 2, 3, and just think about it. For the first slot, and they're all independent, so basically we can repeat stuff, right? There are 5 bars out of the 10. So that would mean the odds of not getting a bar, right, would be 1/2 or 0.5. Hopefully that makes sense. Okay. Out of these 10 things, 5 are bars. So if I don't want to get a bar, I need to get either the lemons, cherries, or a bell, and that's a 50% probability that's going to happen. Well, if it's 3 slots, I'd have to do that 3 times. So that would get me to 0.5 times 0.5 times 0.5, which, if you check, I'm going to check my math here, but I believe that's 0.125. Okay, so that would be the probability of not getting a bar, right? Okay, but that would mean that's your odds of winning if you play the slot. And if we're going to do it twice, well, it would just be 0.25 times 0.25. We do it twice, so that would end up being something like, I used my calculator earlier. Yeah, it's going to be 0.10156, so round that off to approximately, that's approximately 0.016 would be the likelihood of that happening. Okay, so that would be our answer. 0.016 is the likelihood that we would play that twice and win. Okay, so now what about this one? This got truncated a little bit. We have a test that has 3 parts. It says in part 1, student has to answer 3 out of 5 questions. Part 2, 2 out of 4, and part 3, 3 out of 6. How many ways could the student complete the test? Well, this basically, don't overthink this. We've got 3 different combinations, right? So I have 5 questions. I need to get 3 of them. The order presumably doesn't matter. So I have something like this. I have 5 questions, and I need to choose 3 of them. That's for the first part. That's for part 1. And then for part 2, I need to choose 2 out of 4, so that's 4 choose 2. How many possible combinations could that be? And then number 3, 3 choose 6. So that's 6 questions, choose 3 of them. And all we'd have to do is just calculate what are the number of combinations that we could do for each of these, and then multiply those 3 numbers together. Those would be all the different ways that we could complete this test. So I'm going to cheat here because I'm lazy. I don't feel like writing that full equation out. But I believe, let me see, where is this now? I was pulling up a formula for permutations because naturally I forgot what it was. Oh, here it is. So what's the first thing we have to do is 5 choose 3. Oh, I just did that already. 5 choose 3, that's 10. There's 10 different ways that we can do that. So that's 10 ways there. 4 choose 2. How many different possible ways can we have that happen? Let me see here. Oops, why is this freezing up on me? There we go. 4 questions. Let's choose 2. And we want combinations. That's 6. All right. So there's 6 ways that could happen. And then let's see, this one, 6 choose 3. 6 choose 3. Now the wording on this isn't super precise. I'm presuming that order doesn't matter. And that's why I'm using combinations. But they didn't really specifically spell it out. Okay, there's 20 ways that could happen. All right. So if the order of which question you chose matters, then that's going to change things up a little bit. We'd have a much larger pool of things. But all right, so there's 10 different ways that I could get 3 out of those 5 questions right for the first part, 6 different ways for that one, 20 different ways for this one. So the total number of ways that I could do this, since these 3 parts, is just multiply those 3 things together. 10 times 6 is 60. 60 times 20 is, I think that's what, that 1,200, I believe. 1,200 different combinations of completing this test. All right. So what about this one? One of the states in the U.S. wants to make auto tags with a combination of 3 letters followed by 3 digits. Assuming that letters and digits can be repeated, how many different tags could be made? Okay, well, how many different? Again, this seems to be kind of a combination question, so it looks like what we'd have to do here is we got to take into account the fact that if I've got 3, let me just do this real quickly here. I've got 3 of the letters and then followed by 3 digits. Presumably, if I did A, doing a permutation, if I got A for this one and then A for that one and then A for this one, they would count that as, I'm babbling here. Hold on a second. Let me pause and clear this up, clear my head. 1 second. Okay, I'm back. Sorry about that. I was confusing myself. I was overthinking it. Okay, well, if it's just how many different tags could be made, digits and letters can be repeated, well, if you think about it, for the letters, I've got 26 different options here, 26 different options there, and 26 different options here for the first 3. This looks like this is a straight up permutation question. All right, and then it says if we can repeat the digits followed by 3 digits, well, there's 10 possibilities for digits, 0 through 9, right? So it's 10 there, 10 there, and 10 there. I'm not entirely sure what that is. It's going to be a very large number. Let's see, 26 cubed is 17,000 times 10 times 10 is times 1,000. Gets me to 17,566,000 different possible ways that we could combine, the 3 letters and 3 digits. Okay, all right. Kind of zipping through this fast. Please let me know if this is not making sense, and I will do a follow-up video or clarification. Okay, so what's this one now? Celine wants to arrange her textbooks on a shelf. She has 3 English textbooks and 3 math textbooks. Okay, so far it sounds like permutation, right? I've got 6 slots, 1, 2, 3, 4, 5, 6, and I just have to decide what goes in there. But they threw a little complication in here. They said we want to alternate the order of the subjects. How many different arrangements are possible? Now, it's not entirely clear what that means, but I'm going to assume, and this is the basis of the problem, I'm going to assume that that means we have to do something like I have to pick one math book and then followed by an English and then a math, right? Something like that. Or I might start the other way around. Start the first one as an English, then math, then English, and so on. Okay? And that's the assumption that I'm going to make to complete this problem. So if we do that, basically, we can kind of do this 2 different ways. I'm going to do sort of the brute force method, and then I'm going to do the other method. And hopefully these make sense. So let's say the first time we want to do the arrangement. We have 6 total books, so 6 slots. But let's say option number 1 is I want to start with math first. And then option number 2, let's say we start with English. Okay, well, if I start with math, so this is the math side right here. Okay, and this is the English. So if I start with math, well, I've only got, my first book is going to be a math book, there's 3 different math books that I have, right? So I've got 3 options to place for that, right? So far, so good. And then the next book would then presumably have to be English, and there's 3 options for that. And then now back to math, but I placed 1. So now I only have 2 left to place, and same thing for English. I've only got 2 options there. And then back to math again, only 1 left and 1 English left. Okay, and you can hopefully see it's exactly the same thing for this one. I've got 3 options for English, 3 options for math, now 2 for English, 2 for math, 1 for English, 1 for math. You work this all out. If we start with math first, okay, we've got 3 times 3 times 2, what is this? 9 times 4 is 36. So there's 36 different ways that we could arrange our books if we start with math first, right? And then there's also 36 different ways that we could arrange them if we start with English. So the total number of different ways that we could arrange these things would have to be those things added together, which would be 72. Right? Okay, now another way that you could think about it would be, if you're going to be a little more perhaps geeky about it, let's do the same thing. We got 6 slots. And that is, all right, so for the first slot, I've got complete options. No matter what, I've got 6 different things that I could place in the very first slot, right? All right, but now once I've done that, if we're alternating, now that means the very next slot, I'm going to have to be more restrictive. There's 6 options here, but think about it. There's only going to be 3 options here. Because if I started with the math one, then I'm forced to do English, and there's 3 things for that. If I started with English out of that 6, then I'm have to do math, and there's only 3 options for that. So that would force me to do this. All right. And then same thing goes next. If after I've placed this one, we have to alternate again, how many options do we have here? It's got to be 2, 2, 1, 1. Pause the video for a moment and just think about what I did there. It's the same thing as this. It's just instead of breaking it up into 2 different permutation slots and then adding them, we could just make it 1 and realize just with the first one we have the most freedom as to what we can choose. But once I've done that, then I'm locked into only 3 here, 2 there, 2 there, 1 there, and 1 there. All right. And if you multiply all that out, we also end up getting 72. Okay. So just a couple different ways that you can think about this. This video is getting rather long. I'm going to pause here, upload, and then we will continue on with a few other additional stats questions.